Welcome back everyone to the solutions lecture for the Numpy exercises. Let's go to the notebook and go through the solutions. Okay, here I am at the Numpy exercises notebook. The very first task was to import Numpy as NP. We went through that in the previous lecture, so hopefully you figured that out. Next was to create an array of 10 zeros. Hopefully you remember that you can just say NP zeros and then call 10 here, and that creates an array of 10 zeros. Let's zoom in one more level here so we can really see it. Next was to create an array of 10 ones. So one way to do that is just say np.ones, shift enter, and then you have your array of 10 ones. The next one was create an array of 10 fives. Now obviously there's no np.fives, but what you can do is just say np.ones, 10, and then use broadcasting to multiply it by 5, and there you have your array of 10 fives. The next question was to create an array of the integers from 10 to 50. So the way we can do that is say np arrange, and then we want to go from 10 to 51 because we want to go one extra since we actually want 50 included. And this sort of formatting here is just because I'm zoomed in so much. If I zoom out, you'll see the format starts to fix itself. Okay, let's zoom back in. The next one was create an array of all the even integers from 10 to 50. So that's easy with np arrange. You just need to say 1051 and then specify that you want the step size to be 2. And then you have the array 10, 12, etc. all the way to 50. Next, we wanted to create a 3 by 3 matrix of values ranging from 0 to 8. So you can see here we have 0 to 8. The easiest way to do this is just with the reshape method using np-arrange. So we'll say np-arrange, and we'll go from 0 to 9. 0 is the default start, so I just need to say 9 here. And then I will reshape this to be a 3 by 3 matrix. And there you have your answer. Next, we wanted to create a 3 by 3 identity matrix. For that, all you have to do is say npi3, and that creates the 3 by 3 identity matrix. Next was to create use Numpy to generate a random number between 0 and 1. So for that, we can say np.random.rand, and if you remember, this gives you random values in the given shape from 0 to 1. So we're just going to say, just give me one number there. And there's your random number. Next was to use Numpy to generate an array of 25 random numbers sampled from a standard normal distribution. So the way you do that is you just say np.random and we call rand_n here. And then we want 25 of those. And that gives you 25 random numbers. Obviously you won't get the same random numbers that I do. Next we create the following matrix. And let me zoom out so we can see this properly formatted. So I want you to create this following matrix right here, and it goes from 0.01 in step sizes of 0.01 all the way to 1. There's a couple ways you could do this. One way you can do it is the following. We can say np.arrange, and I'm going to start from 1 and go to 101. So I'll start with this, and this gives me 1 to 100. What I could then do is say divide this by 100. And I can see now this is giving me 0.01, 0.02, etc. all the way to 1.0. But right now this is just a single dimension. Notice the brackets here versus the double set of brackets here. So what I want to do first is reshape this. So I'm going to say dot reshape this into a 10 by 10 matrix. And now I have the exact same matrix that I have here. So again, 1 to 100 divided by 100, but I want to reshape it to a 10 by 10 first, so it matches this output exactly. Next was to create an array of 20 linearly spaced points between 0 and 1. To do that, we just say np linspace, go from 0 to 1, give me 20 of those. And there's the results. Up next, we wanted to use NumPy indexing and selection. So we start with this particular matrix, this mat np.arrange. It goes from 1 to 25, and it's a 5 by 5 matrix. So the first thing we want to do is grab this matrix right here. You can zoom in one level. It goes 12 to 15, 17 to 20, 22 to 25, which is basically right here, these 3 subsections of those rows. So what we can do in order to get that is the following. We'll say, give me the matrix, and the rows we want is starting at 2 all the way to the end, and then the columns we want is starting at index 1 all the way to the end. And that gives you back this matrix right here. Next one we wanted is to just grab the singular number 20. So if we take a look at the matrix again, we can see that the singular value 20 is located right here. So in order to grab it, we just want to say, give me the number at index row 3 and column index 4. And that gives you back the number 20. Next, what we wanted to do was grab this subsection of the array, 2, 7, 12. So if we take a look at our matrix again, we get 2, 7, 12, and where are they? They're right here, 2, 7, and 12. So what we're going to end up doing is the following. As far as the rows are concerned, I want to grab everything up to but not including row index 3. And then the columns I want starting at index 1 and going up to but not including 2. So the reason we do that is this is basically the same way as saying the first indexed or index 1 column here. If I just say the following, 1, then I get this back in a flat form. So if you want this exact same format, what you have to do is use a slice notation. So notice the difference here. While it's still the same data, the formatting is different. So it's 1 column 2 instead of just 1 here. All right, the next question was to grab this array. So let's take a look at our matrix again. So this looks like just the bottom row. So in order to do that, the way we can do it is just say, get me row, everything for every column. So row 4, everything at every column, that's how it is. Next one, if we take a look at the mat again, 16, 21, so it looks like just the bottom 2. So we're going to say, give me rows 3 up to index 5. We can actually say even all the way to the end here. And then we'll grab every column from that. And that returns back the same result. Now we want to do the following, get the sum of all the values in the mat. That's actually quite simple. All you need to say is mat.sum. Execute that, and that sums up everything in the matrix. To get the standard deviation, hopefully you're able to figure out through some exploring using tab that it's just going to be std for standard deviation, and then we have 7.211. Okay, and the final question that was not the bonus question was to get the sum of all the columns in mat. And the result should look like this. So the way we do that, if we take a look at mat, we can actually call mat.sum, and we have an axis argument that we can provide, where the axis argument will indicate whether you actually want to sum it along an axis. So if I say axis equals to 0, I get back this result right here, 55, 60, 65. And if I say axis is equal to 1, this will actually sum along this axis. So it sums every value in the rows together. So this might be a little confusing at first, but the notation of 0 and 1, it comes from the fundamental shape tuple. So if you take a look at your shape, you have an index at 0 and an index at 1, where 0 represents the rows and 1 represents the columns. So that's where those axis numbers are coming from, 0 and 1. And then when you call a function such as sum, and you provide it the axis argument, you're basically indicating which axis do you want to execute this along. If you don't do anything, you just say none, it's going to sum everything together. But if you say something like axis equal to 0, remember that stands for the rows, what it's going to do is run that function along the rows. So it's going to say 1, 6, 11, 16, 21. That all sums up to 55. This is a little unintuitive to think about at first because you may think that you want to sum the rows, you would say axis 0, but it's really what dimension do you want to run this along. So you want to run it along the rows. If you want to run it along the columns, then you would say axis equal to 1, and that would sum up essentially what is the rows, but it's running the sum along the columns. Finally, the bonus question. So we worked a lot with random data. How do you actually ensure to always get the same random numbers? You can say np random.seed, and this will allow you to set a seed for the random number generator. So if you set the seed to 101, and then you ask for np random.some random integer, just one of them, you will end up getting the exact same result. Now, if you end up running this multiple times, you'll still get a different result every time, but you'll get the same result in the same order that I do if you set your seed to 101. So sometimes we'll set seeds in order for you to get the same random numbers that I do. So keep in mind, if you ever see the seed, that's what I'm doing here. So if you ever need to kind of reset your seed, just run that cell again, and you can see we always get back 0.516 as long as I run my seed right before that. Okay, thanks everyone, and let's head over to the next section where we'll discuss pandas.